we've already had 2 people question the title of my talk. Why is it part 5? Why is it returning the values? And why would values make a return when the topic is value-oriented programming? Like, where did they go such that they have to make a return, right? Well, the last talk was, you say you want to write a function, value-oriented program, part 1, functions, right? So this is the follow-up to that one. And as you can see here, there is a reference to Star Wars on this slide. Where's the dots?
4.
Yeah. Just got the color and the dots, right? So, oh, by the way, from now on, this one's part F. Like, I've changed this in the future. This will be part F. And for those Star Trek fans, there are 4 dots. So, good. Got to get them both in there. Anyhow, should maybe this be part 2? That was part 1, but like, why are values part 0? Like, values should have come first, whatever. And then I was like, no, part 5, V for values, right? And part 5, it's like return of the values. Oh, wait a second, that's episode 6 is Return of the Jedi, right? But I wanted part 5 because it's V for values, and like, if you're a purist, well, I'm sorry, right? Like, I really like Firefly. It's my favorite. All right. So this is return the values. We are going to talk about values. That's why it shows up in the title at least twice. But what do I mean by value? And in particular, what do I mean by value-oriented programming? Which sounds like a reference to object-oriented programming, which by the end of the talk, you'll get the joke. It's a reference to objects. You'll get it later. It'll be good.
We cut it the first time.
Yeah, it sounds a little bit like object-oriented programming, but we want to talk about value-oriented programming. So maybe we need to start talking about objects first a little bit before we can talk about values. So here's the standard, what the standard says an object is.
Spoiler for my talk.
What's that?
Spoiler for my talk.
Oh, yeah, object lifetimes. Yeah. You can get, maybe in your talk, we can get pedantic about one letter in this whole. Wait a second, I think I had things I wanted to say there for a sec. Why am I going? Okay. Right. So the standard says everything, every variable, everything but functions basically is an object. Like, all the things are objects. But like, I don't think an int as an object-oriented class or something, right? So most people think objects is object-oriented, classes are object-oriented, maybe not ints. So I'm going to stray from what the standard says is an object to more like what we think of an object when we say object-oriented. But then again, like, would you call the one on the left an object and the one on the right is not an object? Because this one's a class and it's object-oriented and blah, blah, blah. The other one's just an int. But like, they're the same, right? They both hold the same stuff. Like, I can do all my image processing with either of these definitions of color. So, when we say object-oriented, it's still not quite just classes, right? And this is why once upon a time I said class does not equal object. This is object-oriented, right? This is the classic object-oriented, and we've got hierarchy and inheritance, and the Sean Parent quote of inheritance is the base class of evil, that kind of stuff. And it's not even so much that it is objects, it is code oriented around objects. And as another example, there's this. I like this one. Classic object-oriented programming. But so that's kind of what I mean by objects. I always have a few. There's always community members around in my talk are like, no, go back to the C++ definition of object. I'm like, my definition is different. So what do we mean by values? That's what we mean by objects. What do we mean by values? Int is the canonical value type, right? It's like, whenever we talk about anything else, does that act like a value? Well, it's like, does it act like an int? Because int is our best example of a value-oriented type. And then that's why I say either of these can act like a value, because they're easy to treat this the same way you would treat an int. But we'll get into that a little farther. But first, like, what's the whole point? What's the problem I want to solve with the values versus objects? And the problem I want to solve is entanglement. Big, giant letters, big, giant problem. Yeah, all my experience tells me the problem is you don't keep your code separate. I don't care about OOP, I don't care about the language, don't care where you put your brackets. Just keep your code separated and name things well. I always got to throw the naming in there. And then somehow I'm going to claim that, value-oriented programming, whatever that means, let's hopefully find out, will help with this problem of entanglement. And you can break entanglement down into, these are very similar to each other, but I kind of separated them out. They're subtly different. Spooky action at a distance, some code here causes code over there to change, or state over there to change. And the more general case of just non-local reasoning. I want to look at code and reason about this code without having to know all the code. I want local code. KISS, keep your stuff separate. It's the new, it's the new version of KISS. All right, so how does entanglement and objects go hand in hand, or do they, or whatever? And basically, why do objects suck? Sorry. So objects, I have two, pieces to that puzzle. Nexus of complecting, which I'll explain, and graph of references. Nexus of complecting. Complecting is this word. It's an old archaic word, but Rick Hickey, who wrote Closure, he brought it up in a talk, and he likes bringing up archaic words and bringing them back in, and he looks everything up in Latin. And simple and complex both come from the same Latin base, plecto, meaning to braid or to intertwine or to entangle. So complecting is the process of interweaving stuff. So complecting is what we do with our code every day. We entangle it and everything. And if you were here a few years ago, I had a talk. Well, actually not here. I think that was the virtual one. I had a talk on complecting made easy, because the point is it's the easiest thing to do. Whenever you write some code, and you think, oh, I could just fix this by adding an if statement, or I could just do this, or it's always the easiest thing, and it's almost always the thing that complex your code. But it's the easiest thing, so you do it, right? So his talk was simple made easy, but simple is hard. Complecting is easy. That's the easy part. So you should go watch that talk. Not right now. Maybe later. So what do I mean by nexus of complecting? Here is basically a class in my code base. I should probably explain. This is what I do at work, is we make projectors. Christy makes projectors. In my team, we shine projectors on an object, put up some light patterns called structured light, and then I can color the object, because I know where the object is in space, and I can project on. It's called projector mapping. And I think, this is a model car. This is a dark gray car, trust me. And we're projecting, the color. We're projecting everything onto that car. There's no brakes on the car. It's just all fake. So that's what we do. So I bring it up because, why am I talking about cameras? I'll be talking about cameras. I'll talk about projectors. That's what we do, right? You project with the projectors. You look at it with cameras. You solve the world. And I just have to mention that I worked at a lot of different companies, big companies, small companies, like Adobe and all these other companies. Everyone has bad code. There's all code everywhere is bad. So I'm going to show you examples of bad code. It doesn't mean all our code is bad, and our company, has bad code. Everyone's got all code's bad. This is our camera class, and it basically is, the class is called camera. So if it has anything to do with cameras, it's in this class, right? Let's see, what else do I need to say about this? Yeah, it's just the everything related to camera class. And you'll notice some things, it makes a lot of sense, A camera has an ID. It's a one-to-one relationship with every camera has one ID. Every ID has a camera. There's a device path that I can it's the IP address or whatever it is, depending on what type of camera, that I can get to this, talk to this camera. actual physical device outside the computer. But all these other things, a lot of them are like 1 to 0 or 0. Like I don't often know the pose. The pose of the camera is like, where is it in 3D space, in actual, physical space. I don't know that till I've solved the world. At first, I just take pictures with the camera and I figure out where the camera must have been to take a picture from that angle. So half the time, this camera class, it's not full of stuff, and I hate classes that are like, oh, it's just some of this, and it's really hard to tell. That pose isn't even like an optional pose. It's just, oh, it's all zeros. Is that actually at 0, 0, or is it just hasn't been set yet? And a lot of these pieces of like what mask I'm going to use and base image and negative image, that's pertinent while the process is happening, while we're taking pictures. But before and after that, it shouldn't be there. Those should be like local variables, literally local variables in the process of calculating the world. Somehow they just got, every camera has a base image, so let's put it on the camera class, right? So classes are made of Velcro. It's just like you just keep adding stuff to it. It's like, oh, where should I put this? Oh, we get another mask. Actually, we just added another mask. There's 3 masks into this class now because you can draw a custom mask for various reasons. And I had a student working on it. He's like, where should I put this? And I'm like, camera. Just put it in camera. So it's just got one more thing in it, right? And then it's like every function on camera, now you have to go, like, because it doesn't just have, I'm not showing all the member functions. It's got another giant list of member functions. All those member functions, maybe they're affected by this new mask that we just added to the class. And it's like, oh, what does that break anything? Like, how do you maintain when there's so many things too close together? And I picture it this way, right? You have all these separate concerns that you've tied, and they are related to the camera, but you've tied them so close together. You put them in the same class, and if you touch one of them, if you touch the blue line, you're going to break the green line, right? Just accidentally. And you can go back to the solid principles and things like that. Single responsibility. It's like, oh yeah, camera. It's got one responsibility. It's the camera. Anything about camera, that's it, right? But and this isn't necessarily inherent into object-oriented programming, but it just happens all the time. It just comes along for the ride. It doesn't have to come along for the ride, but over and over again, it does come along for the ride. And maybe that just there's other ways to deal with that, but like it's somehow object-oriented programming encourages this, because you feel like, well, in some languages you have to put all the functions on an object, right? Not in C++, but a lot of languages, they really encourage member functions. And then you put a member function on the camera class, then you realize, oh, this member function would work better if I had one more member variable. And then, you add member variable, and then you add a couple more member functions to deal with that member variable, and it's made of Velcro. It just gets bigger and bigger. And so that's nexus of complexity. The other half is non-local reasoning, right? And you could say the camera class, it's local reasoning. It's all inside the camera class. It's all local to the camera class. But when the camera class is this big, the class itself is not local. It's like, hey, everything in my program is local reasoning because I have a class called program. And everything's inside of it, and I've encapsulated everything. And it's great.
It's like, not local, it's a locale.
It's a locale, yeah. It's a region. Small continent. What else do I want to say? So that's mostly about complecting. Now let's look at graph of references. And if you talk to other value-oriented programmers and anything about value-oriented programming, which is, I hope, now a term. Like, I've been pushing that this is a term for a while now, and I think it's catching on.
It's a whole language. It used to be called Val.
Yeah. And then like there's a lot of if you go watch there's always a lot of Sean and Dave and I agree on a lot of things from our talks. I mean, I've got slides from Sean. You'll see them later. Like, it's called high-low now, right? Val, yeah. Actually, some more of that will come up just shortly now that I think about it. So here's a graph, right? Classic. I don't know what, I'm like behind the times, Game of Thrones. I don't know, what's the current TV show that has like backstabbing and, But this is a good one for like graphs, right? It's just, I just needed a picture of a graph. So you get, like, my claim is this is what our code looks like. You have references to other objects all over the place, and it forms a graph. Your whole code base, your product is this big giant graph of this points to that and points to that, and you have references to everything. And like, it gets to the point where if everyone has a pointer to your object, it's basically a global variable, right? And you're sharing pointers everywhere. And speaking of Sean, a shared pointer is as good as a global variable, right? Like, as soon as you start sharing these more and more, okay, everyone has access to it, right? And we do, global variables are still bad, right? That hasn't changed recently? All right.
Unless you're mold.
All right. Tangents. Let's stay off the tangents. Yeah, this is your code on references. This is your code. This is your code on references. Yeah, incidental data structures. Another Sean. Steal some slides from Sean. He said I could. So let's imagine I've got this class A, whatever it is, and it points to another thing X, and this forms this object, right? And you think about it, it's like, whatever this is employee record and address. You decide to make address a separate object, or it's whatever. I don't care. It's, you get this all the time in your code base, right? Some object that has a child object. And then you got another one over there. It's got a B. It also has an X in it. It's like, okay, great. But like, maybe they got the same X. Maybe they share an X, right? So now you've got two objects and they just happen to share an X. And it's like, no, you don't have two objects that share an X. You have this data structure, right? And this is why Sean calls it an incidental data structure. You didn't make this data structure and give it a name and make a class out of it. You just shared some variables, and now you have an incidental data structure. And it suddenly becomes slightly harder to reason about. And your mental model, most of the time, is still this. You just think, oh, I've got an A with an X, and I got a B with an X, and everything's fine. And then somewhere along the way, A says, I really want a chocolate chip cookie. Like, who doesn't want a chocolate chip cookie, right? And it's like, I'm gonna, like, X is last week. Now we're chocolate chip cookies. And B's like, I want a raisin cookie. I really like raisin cookies. And you know what? I have nothing against raisin cookies, but when I grab a chocolate chip cookie and suddenly it turns into a raisin cookie, I thought it was chocolate chip. It looked like the chocolate chip, but raisins camouflage themselves as chocolate chips. And that, like, I would love raisin cookies if raisins were like green or something, and going up to it, I would know it was a raisin cookie, right? But I go up and I go, oh, look, chocolate chip cookies. And then you grab one and you're like, oh, this one's, and you see another one that's chocolate chip, and you're like, I've already grabbed the raisin one, and it's terrible. So, come on.
I'm absolutely serious.
Raisins are better. Oh, Ben. Anyhow, your mental model has just been like, this is spooky action at a distance, right? You thought you had a chocolate chip cookie, suddenly it turned into a raisin cookie. And because your model has two separate objects, you have no idea what's going on anymore, right? And then you have to go look at your code and like, oh, what's this bug? Oh, we're sharing this shared pointer, blah, 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 whatever. However you managed to get this state, you've now got this problem, right? And everyone know the quotes? We're smarter than this. How did this happen? We're smarter than this. And Anakin says, apparently not. Okay. Because this happens like it's everywhere in the code base. Every code base I've ever looked at, you get these incidental data structures. And like, I worked at BlackBerry, and the way back when it was Java on the, if you wanted to make a BlackBerry app, it was Java. But I worked on the C++ underneath the Java, all the graphics and stuff like that. And some people would send us bugs saying, oh, the C++, it's messing with my objects, you're overwriting things and blah, blah, blah. Every single time, not like over the course of years, you're sharing your objects. Because that's just the natural thing to do in Java, right? You just pass a reference and it's like, oh, Java doesn't have pointers. It's like, everything's a pointer, okay? Like, and you just share, and then they wonder why something over there changed my thing over here. Anyhow, the other way I describe this is the steering wheel problem, right? It's like, you want to borrow my car? It's like, sure, here's the keys, you can borrow my car. And then you're driving down the road and you're like, suddenly the car goes left. You're like, you're like, what? I'm like, oh, I'm still holding the steering wheel. Can't we share it? Like, there's no problem with that, right? And the car object is completely consistent. The car's like, if you turn the steering wheel left, I'll go left. If you turn it right, I'll go right. It doesn't care that two people are steering at the same time, right? It's not the car's problem. But like, if I hand you the keys to the car and you can borrow my car, you don't expect me to also be driving at the same time, right? So let's avoid the steering wheel problem. All right, so that gives us non-local reasoning and spooky accidental distance because we used references to our objects. And I claim this is very connected to objects. Let's dig into that. To figure this out a little more, we need, of course, to talk about the ship of Theseus, because obviously that's the next step here. I think we all, it's like, I could just skip these slides because this was the obvious. You knew this slide was coming. So if people don't know, the ship of Theseus was a real ship, and they really did try to keep it in pristine maintenance shape and everything. So they would always be replacing pieces of the ship of Theseus, and they would replace it really early. Before, a piece of wood didn't have to be rotted out before it got replaced. It was like, no, man, this is our flagship ship. Let's replace stuff early. And then at some point, the whole ship has been replaced, right? Every piece of wood in the ship has been replaced with a new piece of wood. Is it still a ship of Theseus, right? It's nowhere, it's not the same. And also, you take all the old pieces that they took off the ship, and because they were really high on maintenance and they didn't want the pieces to be that bad, you could actually build another ship of Theseus out of the old pieces because they weren't that bad. So now I have two ships of Theseus, right? Which one's the ship of Theseus? Does it matter? Does anyone care which one the ship of Theseus is? It's like I can sail with either ship, right? Which one? Anyone? Give me pick. Gotta pick B or C.
Rich Hickey's got an answer.
Yeah.
There was a Star Trek episode about this.
Yeah.
Will Riker got.
Yeah. There's two Will Rikers now. Yeah. Yeah. Maybe it has the same solution. So, which one's the ship of Theseus? It's the one I labeled ship of Theseus. Come on, it's right there. It says ship of Theseus, right? Yeah, and like it does, to a certain extent, it doesn't matter because I can sail either one. Either one's going to work. But when I say, hey, let's go sailing this weekend, I'll meet you at the ship of Theseus. It's like, let's make sure we know which one we're talking about, right? Let's go to the right ship. And in C++, we label it by its memory address. It's the ship at this memory address. This is the ship of Theseus because that's the name of the variable and it sits at this memory address. And if I replace pieces of wood, it stays at that memory address. It's whatever ship is here is the ship that has changed over time, right? And that's inherent to objectness is that it is here in memory and you can track its change over time. And you say it's the same object, just like us. Am I the same person I was when I was 7? It's like, not many of those molecules are the same, but somehow I'm still me, maybe. I was as snarky and whatever when I was 7, yes. Yeah, I'm pretty much the same as I am now. Ask my parents. If we go back to, I said there was like one word in this for Jonathan there. I asked the committee, like it says, an object occupies a region of storage throughout its lifetime. I was like, a region of storage. Is it the same region of storage throughout its lifetime? Or could it be here and then sometime later be over here? Like, and be the same object, not like we called move and, move. You feel like you moved your object, but you didn't move your object, you moved the values of your object.
There's paper about that.
Yeah, there's destructive move and all this stuff. But I asked whether we should change the wording to clarify, and Core told me to go away. They're like, we feel this is sufficient to say it's the same region of storage throughout its lifetime. And I'm like, I don't know, I could read this. It occupies a region of storage. At any point in time, it does occupy a region of storage. So I have clarification that is one region of storage. And that's why the ship of Theseus is at that memory location throughout its lifetime. And it's the same ship because it's in the same memory location. And Rich Hickey calls this plop, place-oriented programming. It's the thing at that place. And be very clear that he calls it plop as not a good term. Right? Like he was trying to find a term that, oop is already a bad term. It's like, how do you program oop? Right. So you can have a graph of references in objects because objects have a location in memory. And they have a fixed location in memory, and that location never changes. So now you can have other objects that point to that object, and that lets you build a graph of references. So you don't always have to have a graph of references when you have objects, but objects enable, they're an enabler to the addiction of graph of references. And in particular, when we think of our classic object-oriented with virtual functions and stuff like that, as soon as you have virtual functions and base classes and everything, you almost always end up with, you allocate, and you have a pointer to base so that you can have the virtual polymorphism, blah, 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 blah. It goes hand in hand with, I'm gonna allocate this and have a pointer to it. Michael Park, where's Michael? He's here somewhere.
Yeah, he's here.
Oh, there. Do you remember polyvariant?
Yes.
We talked about it one day. Just like, I have a lot of cases where, like, when you have a class hierarchy, unless you have like something like Photoshop plugins or something like that, where I actually don't know what I'm going to get because this DLL is loaded at runtime. But most of the time, I know what my hierarchy is. I've got shapes, there's circle, triangles, and rectangles. That's all I got. I could make a variant that is like, I don't have to allocate circle, because one of the reasons you allocate is because it's different size in memory. So you allocate so that you can have dynamic space. But like the variants, like, we're as big as the biggest one. But then I still want the polymorphism. So Michael and I made this polyvariant where the first parameter is the base class, and then everything has to be derived from that. And then when you access the variant, it doesn't matter, it knows what type it is internally, and you get the draw function for whatever it is right now. And when I say Michael and I wrote this, Michael wrote it. Like in like a couple of lines in, it's still somewhere in Godbolt. I've lost the link to it. It's there somewhere. But I was like, wouldn't this be really cool? Because he did an implementation of variant for one of the open source, the standard libraries. So like it just came out of his fingers. It was just like polyvariant, it derives from variant or uses variant, and then blah, it just works, right? I was spending all this time figuring out how to make it work. Just talk to the right people. So you could avoid allocation if you really wanted to. But I don't even, I have, the only place I have polyvariant is in a Godbolt link somewhere that I've lost. But I've been thinking of actually starting to use it, write it for real and use it. But usually you just use a pointer, right? Hopefully a unique pointer or something, but just use a pointer. So if you got rid of pointers and addresses, then you get rid of, it's hard to make a graph if you don't have pointers to objects, right? Which is great, no relations. And then it's like, wait a second, there's no relations. Like, I have relations in my code base because they're important, right? Like, I need to know that there's a projector and there's a camera, and I have to keep a list of cameras, and like you need objects and you need like buttons and all these other things. So relations are important. So it's kind of, we can't just nuke it completely. So you can imagine though, if I had a layout class, because I have this shape example, I could either have a vector of pointers to shapes, or I could have a vector of polyvariants of shapes. And kind of the layout class using the vector holds those relationships, but they don't leak outside of the layout class, right? And you kind of can contain your set of your relations. And basically you get these two, you could either do it like this with just vector pointers or unique pointers or whatever you want. And if you wanted to select a shape, at X, Y, you could look through the vector, figure out which shape is at that position. Or you could use some like kind of polyvariant. And the memory representation looks like this. Either your vector has a bunch of pointers in it, or your vector just has the object embedded into the vector. What's the difference between these two? Like, they're kind of isomorphic. One, you can hand out pointers to your objects. And I mean, you could hand out pointers to an entry in your vector, but please don't do that, because you're going to, it's going to get invalidated when you add something. Here, you're probably only ever going to hand out pointers to the layout, right? And you just have gotten rid of this problem of, someone was holding on to a pointer to the circle and then the circle got deleted, right? It's like, don't do that. If you want to talk about the circle, go to the layout. There's a thing called law of Demeter, which basically says, don't do this. Like, you see code that goes arrow, 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 arrow. And it's like, you probably didn't want to do that. It's like, if you want to talk to the circle thing, a lot of times you just want to go through layout, you know? And if you want to get like the color of the circle and all that, yeah, get a circle that's a value type, you know, get a copy of the circle out, and then you can deal with that. But you don't need direct access to the circle. And speaking of Val and Sean and Dave Abraham stuff, they call it the whole part relationship. The circle is just part of the layout, and the whole is the layout. And the layout isn't a thing without its parts. So you want to talk to the whole whenever you can. We all know what this one is. This is
the dark side.
What's that?
B leads to the dark side.
Yeah, leads to the dark side. But what leads to the dark side? State leads to objects. Objects lead to references. References lead to sharing. Sharing leads to entanglement, and entanglement leads to suffering, and suffering leads to the dark side. That's in the extended. You got to get the extended DVD on that. Yeah, pretty sure that's what he said. Okay, so let's talk about values. That's what we're really supposed to be talking about. So back to the ship of Theseus. Are those two ships equal? You know, equality of ships. You know.
That depends.
That depends. That's this.
I have a whole talk about that.
Wait. This is the sign of a C++ expert, right? And I tell my students this all the time. If you want to be a C++ expert, when someone asks you a question, say, it depends. That's all you got to do. Just, it depends. Yeah, it depends, right? Like the ship on top, because it's got the new wood, maybe it lasts longer. The ship on the bottom, ooh, it's a collectible. It's the OG. It's the original, you know, ship of Theseus. Every piece is the original, right? But like, do I care? I want, you know, to go sailing. I want to smoothly sail the 7 seas with my friends. Like either one of these ships will work, right? So it's what's important to the user, what was important to the creator, and what is the essence of shipness? You know, like is the how old this piece of wood is that part of the essence? Maybe it is, maybe it's not, right? You have to decide these things when you build your ship class.
Yeah. And that is what equality defines.
Yeah. And substitutability for equality, right? It's like, can I use either one the same in the functions that I'm going to do with them? And if the functions are just transport my friends and sail the seas, these are equal ships, right? Mathematically, x equals y, if and only if for all functions f of x equals f of y. And there's a star beside all, but you know, mathematically, if this was math, like it's so subtle, but in math, x is 17 and y is 17. X and y are equal because they're both 17. It's not, there's only one 17 in the whole universe. It's the number 17. There's only one of them. And x and y just refer to it, which now gets back to references. But in the math sense, it's okay because 17 never changes. It's always 17. It's a number. You can count on it. So if anything immutable, it doesn't, you can take reference to immutable things because they won't change. They're like values, right? 17 is a value and an object, and it doesn't matter because it doesn't change. And in math, x and y are the same thing. They're not like copies of the same thing. They are the same thing because they're both 17. And then every function is going to give you the same answer because it's the same thing, right? In C++, x and y might have two different memory locations, so they hold the same value of 17 in them, but there's two of them, right? Two objects. So you have this problem of like address of x equals address of y. Oh, well, okay, that's not true. So no two objects can be equal because you can't substitute them into address of. And then you go, no, that's just dumb. And so you say address of doesn't count, right? So you say salient functions, the functions I care about. If it's all functions that I care about, I get the same answer, then it's substitutable and I don't care. They're equal as far as I care, right? And who is I in that sentence, right? It's like whoever's using the class whoever wrote the class, because they probably wrote equal equal, and hopefully it has something to do with the essence of what this class is trying to model. It's like, this class models numbers, okay, 17 and 16 shouldn't be equal in that case, and yeah. Here's a maybe a better example than numbers. Vector, these two vectors are equal, everyone agree? I mean, the standard agrees, like, this might be the only like example code I ever write that actually might compile. I think that would pass. So let's do a pushback, add 13 and then pop it away. They're still equal because there was a 13, but now it's gone. And it's not like vector has this magic memory of like, oh, I've seen some wars. I had a 13 in me once upon a time. And so it's a different vector. It's just, it's been through things. No, these two vectors are equal still. But maybe on that pushback, it changed the capacity of the vector. Maybe it had to reallocate. And so now, do they have the same capacity? And it's like, I don't know. Who knows? Yeah, it depends. It depends. And also, who cares, right? Like the point is, no one cares. And we just say capacity is not salient to the equality of vectors, right? And capacity is not, even though like, obviously sometimes it is important. There's places where you're like trying to optimize code where you're like, hey, if I reuse this vector, I'll get to reuse the capacity. And there's always an edge case where it depends. We're C++ developers. There's some case where I care about the capacity. But most of the time I don't care. And if I think about, what is my next slide? Okay. Users typically don't care. CppNow said so. He wrote vector. I have a lot of faith in CppNow. He probably knew what he was talking about. And the third part is, it's like the essence of shipness. It's not part of the Platonic vector, the concept of vector. And the concept of vector is this diagram, right? If I draw, here's the vector, 2, 3, 5, 7, 11. You're like, yep, I agree. No one goes, he forgot to include capacity in his diagram. Like, why didn't he put some empty stuff at the end of his diagram? I say, I can't tell which vector he's talking about. This is like, no, when you're like, a vector is an ordered container of elements. That's the important part. Everything else is not the Platonic ideal vector. Everything else is implementation detail. So they are not part of substitute. All the details, implementation details are not part of substitutability. They're not part of equality. They're not part of the essence of vector. Address of, CppNow said so. Now this is to remind me that like, let's talk about CppNow and regular and address of and things like that. Speaking of CppNow, that's what that circle was for. This is straight out of 1998. It's not like it's new. You have some object, A equals B. Hopefully, when you construct an object, copy constructor an object, it's called copy constructor, meaning you made a copy. Copy means they're equal, right? So you should be able to assert A equals B afterwards, right? So now I had a circle. Did I miss that part? Come on, why does it always? I had a circle, made a copy. Now I got two circles. They're equal. Pretty simple, right? You can also assert that A equals A. It's not that interesting, but it'd be bad if it wasn't true. Like not a number. Not a number does not equal not a number. Like, good unit test. Check that your class equals itself. And then we can add another thing. Add a C. Make it equal to B. And because we made it equal to B and B equals A, we get transitivity. C equals A, right? All of them are equal. Excellent. And then the really important part is we change A. It's no longer a purple circle. It's a yellow ellipse. Surprise, surprise, B and C are still equal, but neither of them equal A anymore, right? That's not that surprising, except for in our code, it's often not true that, because what happens when you change A, suddenly B and C change because you're sharing cookies, right? It's like, but CppNow has this, regular is a concept before we had concepts in the language. It's the, that kind of concept, but CppNow did all this work on concepts in the language because he wanted to be able to codify what regular means into the language. But that's roughly the definition of regular. And because of this, that's what I was saying, because of the change, I can make a change to A and it doesn't affect B, you don't get this incidental data structure. if you have regular types, because they're disjoint. What's, come on.
Do or do not.
No, this is where he says, it's close. It's raisins have you, must not. Yes. No. It's actually copy or copy not. There is no shallow. That's what he said here. I'm pretty sure that's what he said. Because I don't know how many times I've had to convince people that like it's the simplest thing. You've got a class with a pointer and a thing and like vector or something else. It's like, oh, when I make a copy, should I make a copy of this? Because that would be like slow and terrible. And it's like, can I just do this? And it's like, you guys know this, right? It's like, you just make a copy. There's no such thing as shallow copy. That's just does not exist. All right. Back to circles. Here's a circle. Here's another circle. Are they equal? There's no tricks. It's like I didn't make one slightly smaller or change the shade of purple or something like that, right?
So no, I don't think they're equal because they're in a different place and you don't care.
Well, we'll see. You guys asked the right questions. They look equal to me. So what's in the class? What's in our circle class? Radius, color,
Diameter.
Location.
the XY, any functions?
All the functions.
You don't draw it.
The equality
area.
We got radius is the first thing anyone said, so I got that. Maybe XY, maybe draw. Is it selected? Blah, blah, blah. And so, yeah, like you've already pointed out, if you put XY in the circle class, and maybe color, right? Someone said color, forgot that. I just typed that in now. Let's leave out the member functions for a while. Wait a second, these aren't equal because they have a location and there's different locations. So these aren't equal circles. So this XY must be relative to some origin, right? It's like, if not, what's the point of the XY? Oh, what's the point of the point of the, wow, just thought of that now. So I like to make a distinction of the XY is an extrinsic property of the circle. It's a relationship between the circle and the layout or the origin or wherever the circle goes, right? Whereas the radius is intrinsic to the circle. And even the color is intrinsic to the circle. XY is a relationship between circle and everything else. If you move the origin, if you didn't know the origin, then the XY is useless. So sometimes it's often good to stop and look at your class and think, what's intrinsic, what's extrinsic?
It's a co-located property.
Yeah, it could be in either spot. It's a co-located location property because it's apple class. I just like we have an apple. It has an XY. Do we change, like every time I move the apple, like, do we care? It's, this is an apple. Like, if you're running a game, then I guess you probably care where the apple is, XY location. But still, it's like, it's not intrinsic to the apple. It's like, sure, it has to have a place. Matter's kind of like that, but like, I don't think it's intrinsic to the appleness of the apple. Cameras have poses, except for 90% of the time I don't know what it is in my class. And I don't think it's intrinsic to a camera. I think taking pictures is intrinsic to cameras and everything else is extrinsic. And classes are made of Velcro. We put stuff on the class that, should it be on the class or should it be somewhere else? So what do we do? We could remove X and Y. Where do we put it? We could have another object that's outside called the layout object, and the shape, the circle part, and the shape is just describing the shape, because that's what shapes do, is they describe shapes. And then the layout object has things like, where is it selected or not, whatever other kind of properties. You could go a step further and move the color out of the circle class and say that's a style property, because you're not just going to have color. And a month from now, you're going to have like the border color, and then you're going to have gradients, and then you're going to have whatever. And the circle class is constantly going to change because you put color inside the circle. It's like, well, maybe that should be outside the circle class. And now we have a circle class that has a radius, and we're like, yeah, I think that one's going to stay, right? Like that's, that one's kind of important. And the thing is about it is like, you found a foundational part of like, this isn't going to change. Like, Ben has a talk that I haven't seen yet about coding about change. Yes, that's the title of it. I want to see that talk. I don't know if it's related because I haven't watched your talk yet.
You weren't there in Toronto?
I was there, but I was like doing my slides. Like I don't go. This is why Hannah forced them to put my talk first so that I actually see the rest of the conference. It's great when you find something that's not going to change in the code. It's like everything else about this code might change, right? Like the style stuff and how we do our layouts and so many things are going to change. The radius isn't going to, well, okay, it's going to turn into a double or a float one day because someone will want sub-pixel precision. But it's like fundamental, and it's like, I love it when I find something and like, this is correct, and it's not just correct now, it's correct forever. Like circles have radiuses, check with math, nope, they say it's not going to change, that part's going to stay.
That's also a Stefano quote, by the way.
Which?
Write code so that you never have to change it.
Write code that you never have to change it, yeah. Yeah, you find that little gems of pieces that don't change. Yes?
But aren't all circles the same regardless of radius? And it's just when you
A
put them
scale?
in the coordinate system.
Yeah, there's only one circle. It's the unit circle, and then there's a scale factor. Yeah, I thought about that when I was making the slides. And should have figured only here. I did this talk somewhere else. No one brings that up except for here. Keep your stuff separate, right? And I'm not even saying this is necessarily the right organization, right? Actually, your other choice is rename the class to circular region. And then you're like, oh, okay. If it was circular region, I never would have thought those were equal. I would have, right by the name of the class, I'd be like, those are two circular regions and they're not equal, obviously, right? So it goes both ways. It's like, what's intrinsics, what's extrinsic? Yeah, I was saying something, I think I've said this before. Oh yeah, I tweeted it. If you can't name it, you probably don't know what it is. If you don't know what it is, you don't know what it isn't. You don't know what to take out of it. If you don't know what it isn't, you don't know what code shouldn't be in it, and so much code shouldn't be in it, right? So get the name right, and then it helps you define, it's a circular region. It has an XY. It's obvious. Essence is the essence of naming. That's
also one of your tweets, isn't it?
Yeah, it's somewhere, yeah. Okay. I wonder what slide I'm on. Yeah, we're good for time. We're going to talk about functions a little bit, which sounds like, oh, we already talked about functions a year ago. But there's a couple parts that I want to extend or talk about or remind you or something. We can't talk about classes and object-oriented and values and stuff without, like, values and objects are kind of useless unless you have code that actually runs, and that code is probably in a function somewhere, so it's important to talk about functions. So here's our draw function, classic draw function. And if you watched the talk last time, it's like, nope, that's not inside the class. It's outside the class. It's a draw function. What else does this draw function need, right? Takes a circle. If X and Y are not part of your circle class, and maybe color is not part of your circle class, you pass all these things in. Is that good? What else does this draw function need?
The target.
The place to draw.
Yeah, the surface to draw on, right? And how many, who's drawn a circle before in code? How many, like more than 5 different times you've written that code, right? Like I've at least 5 to 10 for me of how many times I've written draw circle. And the thing that changes is where I'm drawing it. Like I've drawn it straight into pixel memory. I've drawn it into, OpenGL or something, or Microsoft GDI, or like whatever surface thing. Back when we had to, like at Adobe, it was like you draw it this way on Mac, you draw it this way on Windows. You draw, like I've drawn way too many circles. Love Bresenham, but the rest changes. Similarly, serialize, things like that. All these functions that shouldn't be part of circle. Collides. How do you do collides as a member function? It's like every shape knows every shape. Like that's the double dispatch problem. Which function should be inside a circle?
Radius.
Yeah, radius, get radius, set radius.
No set radius.
No set radius. It's just like, I mean, if it's just in the constructor, yeah, I'm not. There's so many times I love that. Sometimes it's just like, yep. If you want to change it, just make another one. I mean, because it just has radius. It's just an int now.
Just remove all of them and write struct.
Slow down. You're one slide. Let's just go one slide. What are the invariants of the circle class?
Location.
Non-negative.
Non-negative. I don't know. Do you think a negative radius is this? This is a negative radius circle, right? It's a purple negative radius circle. Like, no, you don't like the. I don't see there's any problem with this.
How far does it go?
It goes.
It goes.
All right. So we can argue about whether circle has any invariance at all, but if you are okay with negative radius, then you could just be like, there's no invariance. There's no wrong number, and it can just be a struct. Like you set and you get. There's nothing, a better example is point class. There's no relation, there's nothing like, oh, x has to be less than y, or it's like, no, any x value, any y value makes a point. There's no reason to have getters and setters on a point class because there's nothing you're maintaining. And they're, I mean, you might want a convenience function that sets x and y at the same time so you don't make a mistake and only set x and forget to set y or something like that. But there's no invariance that you're protecting. You don't need any member functions.
It's called an assignment operator.
Yeah, you could just assign from another point. Here's a better example of something that has invariance. This is my code, my actual code. I usually like to slip a goto into my talks, but this time I slipped vector bool. But I honestly, I was writing this thing and I was like, vector bool works here. Like I know there's issues with vector bool. I don't care about them for this. It's exactly what I needed. I mean, I needed a bit set. So vector bool was a good choice. It was there, it's available. So I'm trying to build a graph, right? And this graph doesn't even have colors on the lines. It doesn't have directions on the lines. It is a simple graph. That is the mathematical term for simple undirected graph. And it does this by holding an adjacency matrix. Adjacency matrix, this is straight out of my code. If you have 4 nodes, they're just numbered 0 to 3. If 0 is connected to 1, then 1 is connected to 0, and 3 is connected to 2, 2 is connected to 3. Because there's no direction. If 1's connected, the other's connected. There's an adjacency matrix for that graph. It's symmetrical, so you can throw out half the graph, and you just have this, right? And then this you can transform into a vector using this, A, B, C, D, and as big as it gets, it just extends in this pattern. And this pattern is that numbering, right? The dimensions of my graph, like how many nodes are in the graph, is related to how many bools in the vector by that math right there. And that math was calculated by 7-year-old Carl Gauss. When he was in class, the whole class, this is the story, in school, the class was being rowdy and noisy and everything. Teacher's like, okay, just everyone shut up and hey, give them something to do. Add up the numbers from 1 to 100. Carl Gauss, 7 years old, he's like, puts his hand up right away. He's like, within like, I don't know, it was quick, whatever, right away. He's like, it's this number, right? 50-50 or whatever it comes out to be. Because there's a formula for it. And he was 7 years old and he figured out the formula, right? Sorry, I don't have a picture of 7-year-old Carl Gauss. Anyhow, the important part of all this is not the math lesson, the history lesson. That the member variable dimension and the size of the vector have an invariant between them, and it's that math, right? The dimension and the size of the vector always have to match. Like not be the same, but match across that. I could throw out the dimension and get it from the size of the vector, but it's actually a quadratic. I'd have to take a square root and do quadratic formula, get two answers. One's probably negative. I don't want to do that. I'll just store both things, right? But it's an invariant that I can't allow you. I can't make this a struct and let you just change the dimension, because if you change the dimension, you have to change the vector, right? So that's what I mean by invariant, in case I think this audience understands, but in case anyone was unsure what I mean by invariance, that is a thing that can never be false in this class. It can be false temporarily inside a function while I'm like adding a node to my graph. I have to set the dimension and I have to fix the adjacency matrix. But when I exit the function, this invariant holds again, right? We know what invariants are. Why am I even talking about invariants? Let's just go on. So that's the invariant between those two things. So this is why this thing is a class, not a struct. That's why I have public functions, private data. And then the next step of this class is, what are the basis functions of this class? What to do this, make a graph like that, what functions do we need, right? We need connect and disconnect. What else do we need?
Is reachable.
Sound like a query.
Yeah, it would be nice if we could ask after we've connected. Why don't you just remember? Like you called connect. Yeah, connected would be nice. Node count, which is basically the number of, like the dimension, the number of nodes in the thing. That's kind of what we need, right? Why did I write this class? You guys probably don't know. I wrote this class to do graph coloring. Long story, but I need, in the practical use of putting projectors onto objects, I need to solve the graph coloring problem. I don't need to, but it can make my code more efficient if I do. We won't get into it. I need to solve the graph coloring problem where no two connected nodes have the same color, right? So I can have a solve coloring function. That was the whole point of writing this class. It's good. It's like, nah, there's no reason to make this a member function, right? I have all the pieces I need to write the solve coloring. I can connect and disconnect, and I can check if something's connected, and node count. I can write that function now. Classes are made of Velcro. Don't want that function to be part of my class. By keeping outside the class, I know that it's not going to accidentally break the invariance of my class. There's only 4 functions that can break my invariance. I can add a bunch of functions outside the class and know that I haven't broken anything. But yet, I added a bunch of functions to my class. Why did I add these functions? Disconnect, you can just disconnect the whole node instead of making a single disconnection. You can connect all nodes, you can disconnect all nodes. Total connections, I think all of those probably. 1, they're convenient, and 2, it changes an order n operation to like an O1 operation, like connect all nodes. Well, loop through all the nodes and say, connect A to B and B to C, and think that it's like, no, go through the vector and set them all to 1, right? Or like, I think I'm basically taking n squared down to n is probably more appropriate. It's even the disconnect, right? Yeah, it's inside the vector, it's just a range of the vector for any one node, all its connections are the next few items, yeah?
There's a question there, Antonio, on the solving coloring. You said you want to get rid of it because it could break invariance. But it's a constant function. Does that limit the argument about that?
A little bit, but so the question is whether being const limits the argument of like, is it going to break invariance? It's const now, for one. Actually, it's actually kind of funny. Solve coloring should be const. To solve coloring, I actually make a copy of the graph, and I do start removing connections as I solve the graph. So probably if someone wrote this on the graph, they would trash the graph, or just anything accidentally like these functions. Well, I shouldn't even say that. I don't know. You're just increasing the risk, right? It's closer. It goes back to complecting made easy. You've put this function inside the class, and then one day you're like, oh, I could just fix this problem I'm having if I just make this not const, or just do this one thing, or just temporarily change dimension. I know it's const, but I will, const cast it or something. I'll do, I'll make dimension mutable because I just need to solve this problem. What's the easiest way to solve this problem? And it's like, it's close at hand. So that's the other thing I skipped over with the complecting. The other word in that simple made easy. Simple comes from plecto, complex, complecting. Easy comes from adjacent. Like the root original Latin word was about adjacency. And complecting made easy, it's because the easy thing is close at hand. If you want to solve a problem, you do like whatever's closest. So I want to keep this away from that stuff. And the other things I added was begin and end iterators on a node. You can find what are the other connections to this node without having to check everyone. Is node 3 connected to node 5? Is it connected to node 6? I would have to iterate over all the nodes. I just want to know, just give me the ones that it's connected to. Again, this is a group that knows this, but that's the basis functions, right? Here's your like minimal basis function, and here's your like, nice set of basis functions. And I claim that I will probably never add a function to this class.
It's the efficient basis.
Yeah,
according to
the
Spark.
efficient basis function, because I've changed some n squareds to n's, and one or two of them might just be for niceness. I don't know. I think almost all of them are for efficiency. But
And as far as self-coloring, the argument against self-coloring is that basically any coloring solver can operate on anything that has a connected iterator. So you actually shouldn't have a coloring solver specific for this class. You should have a coloring solver for anything that presents an adjacency graph interface. Yeah,
that's true. I could have a coloring solver that takes a generic form of this. I only need a few functions out of this. It could take any, but you know what? I don't need that. I don't need that. I'll keep it simple. And as soon as I have another one, I will refactor that. But that refactoring will now be easier because it's not too tightly tied to this class. It uses.
You might have different coloring algorithms. Like 2 coloring is trivial, but 3 coloring is not.
Yeah, a lot of different algorithms, but they'll probably all use the same. Yeah, as soon as I need a connected graph, but I also want to color it, the connection part, or not connected, a directional graph, I should be able to color a directional graph. The coloring doesn't change, and I should be able to use the same coloring function. It's a different graph type. And when that happens, I will easily turn my connection function into either taking an interface or templatize it. It'll be fine. Yeah?
Is the no accept relevant, or don't worry?
You can always solve the graph. All graphs can be colored.
Some of these functions have no accept, some of them don't.
Oh, no, it's probably whether it, like connected should be no accept. It's probably whether it fit on the slide. Yeah. I mean, this also has, the real code has, I do use the no discard, but I purposely removed those because, they just take up space.
All graphs can be colored, but not all graphs can be colored without allocating memory. And there is.
Well, you could brute force so graph coloring is an NP hard problem, by the way. So my graph coloring function doesn't always get the best answer, and neither does yours. The other thing I want to talk about is called calculating versus doing. Here's our colored circle class. And, the boss comes by and says, we need to make it easier to pick colors that go together, that just complement each other or something, right? The boss says so. You're just like, okay, man, I'll do the job, set color to match this color, right? And let's go even further. It's like, let's pass in, because we're using colored circles, we want to match colored circles, let's pass colored circles into this function, and it's a member function. And it takes the color from the color circle, converts the HLS space, blah, 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 does some, finds a complement color. So I tried my best to make a bad function. This one little step you see constantly in code where someone passed a thing, like a colored circle, and the first thing the function does is take the thing that it really wanted. I just wanted the color. And then you're like, why didn't you just pass color? It's like, no, someone from, I talk about this in the other talk, it's top down versus bottom up. Top down, it's like, I have a colored circle, I want to get a thing. And so you pass a colored circle. But when you look at the code, it's like, I just needed a color. Go back, you did top down programming to start, on the way back, do bottom up programming and say, this function should have only taken a color. just a comment. This is easier in HLS space. Why? What? Can you explain that? It's like, I see that you're converting H's. This has nothing to do with my talk. I just hate bad comments. It converts to HLS. Does every case need HLS or just the one case need HLS? This is just, I tried my best. And what was this? I don't even know what that, there was like 2 different things I hated about this line of code. The dot to HLS on the color class. Like that should have been not be a member function of color.
Or the from HLS assignment.
Yeah, we're getting there. We're getting there. It calls get config, which is obviously a global, singleton or something. That's always one of my favorite things. And it didn't actually want the config. It wanted to know what color match mode we were in. Were we doing like complements? Are we doing some other, system? So obviously maybe that should have been something that got passed in. So I don't need to know what a config even is. And then I do my complement plus 180. And if anyone knows anything about colors, like you just went over 360 and you're now into, there is no color in the 590, whatever. Like what number is this? This should have been mod something. Yeah. And then we did the from HLS. That shouldn't have been a member function. And then this is actually the part that bothers me. Like those were all just, you went through all this trouble and you did this function. And the last step of the function is to set the color of the member, this is the member variable because this is a member function, right? So, let's at least fix some of this, right? We'll make it not a member function. We will pass in a color. We'll pass in our color matching model. I still hate some of the HLS stuff and blah, blah, blah. But we don't set the variable at the end. We don't do it. This function doesn't do anything in the sense of it doesn't change the state of your program. It doesn't change the state of the class. It just calculates an answer and returns it. And then outside of this function, you'll call set color, right? This is separate, here, right? You'll call find matching color, and then you call set color. These are 2 steps. You don't make this a member function that does it all in 1 step. And that is separate calculating from doing. This function calculates stuff, and then you take your answer and you change the state of your program. Even just for the sake of testing, your life is easier. Here's another example of this. This is what our code does this is the new way, to show, like I want to project onto an object and I need to know where the projector is coming from. I need to detect all these points that are being projected. I need to know which point is which. Is this the top left point from the projector? Is it the bottom right point from the projector? So I have this really complicated pattern that if I look at really closely, has some parts are repetition and some parts are unique. And every patch, every 3x3 is actually unique. And I can detect, even if I don't see, like some of these blobs I don't even see, I can figure out which blob is which. Like this blob is blob 17 from the projector. I know where it left the projector. I know where it landed into the camera, and then I can solve the world. Anyhow, the function that does this is very complicated. It's like 200 lines of code calling like another 1,000 lines of code underneath it. And the last line of code pushes back the correspondences into the list of correspondence. Correspondence being this camera XY location corresponds to this projector XY location. We projected this pixel and we found it in this camera. That's a correspondence. So we do all this work and we add it to the list of correspondences. And it's like, it's the one line at the very end of the function. Like, don't do that. Like just return the correspondences, right? Like separate calculating from doing. And I didn't notice this until we have cases where, like if I want to change the exposure and see if I get better correspondences. Okay, I want to call calculate correspondences. It might not be the final answer. I just want to give me the current answer with this state of things. Oh, I'm going to change the state of things. Do I get a better answer? Now I can compare my 2 answers. If I've already pushed it into the result vector, it's too late. And the day that we decided to like experiment with this stuff, it was like, and it's not like it's hard. It's 1 line of code. Just take that 1 line of code out. Sure, I can refactor it later, but you could have just wrote it that way from the start, and it's not harder. It's like, it feels a little bit like complecting made easy. This was the easiest path, but this path was not hard. And it's right now it's my number 1 pet peeve. of you change your code to separate calculation from doing, and you'll never regret it. You'll never say that, oh, in this case, I shouldn't have done it that way. Values and move semantics and separating calculating from doing go together really well. And I have also example for that. Oh, it's the same. It's the same line of code. Like those correspondences are thousands of correspondences. It's a big giant vector of point to point, thousands of them, and you just return it from the function. There's no efficiency loss there. It doesn't move. Like, don't worry about it. Just return vectors. And you still see, I have a lot of old code where we pass in things. Oh, the vector, I pass in the vector that's going to be filled and all this stuff. And it's like, now you can separate that. And because it was more efficient to do it the other way, you would pass in the vector that's already your member variable. Like it just leads you to set the state of your program. But now with move semantics, you can separate calculating from doing without really efficiency loss. I have an image class. I return the image, right? Oh my God, images are huge. They're megabytes. It's like it's a move only class. You can't copy that. It has a clone function. Not only do you never accidentally copy my image class, you never call standard move on it because it just works. Like 9 times out of 10, you're just returning it to the next person, or you're passing it along to the it just. There's people who will use my image class for months before they realize, oh, here's the one place I have to call standard move, because it just acts like an int because of the way, it's often in code. You're processing and imaging, moving it down the pipeline, and it just gets returned because you write a bunch of functions that take values and return a value, and then you pass it into the next function which takes a value and returns a value, and there's no harm in making image a move only type. And generate point cloud bothers me because in reality, we have a function called generate point cloud. What's it return? What's it take for parameters? Any guesses?
Return the point plus.
The one we have takes no parameters and returns nothing. Because it's a member function, and it's just somewhere inside the class now has a point cloud. Math, right? It's just make your code look like math. All right, we're getting to the conclusion here. I've been leaning heavily on the value side, but you do need objects, right? Buttons really are objects. If I pass a button to a function and I pass by value, do you get 2 buttons in the UI? Buttons are objects. I'm okay with that. Projectors and cameras really are physical objects. If I could somehow pass a projector by value, by copy, and suddenly have 2 physical $100,000 projectors, my company would be really happy with that technology, right? As long as we kept it to ourselves. Change production, and objects are non-copyable, hopefully, typically. Especially if you have an inheritance, you probably don't want copying. And they're changeable and observable over lifetimes, and then you can make relationships, you can do polymorphism, all these cool stuff. But values are like int, string, point, copy movable. I like that on one hand, you want the values to be immutable, even if your variable's not immutable, like the number 17 is immutable. Int's not immutable, the value 17 is immutable, you can count on it. And yet both ephemeral and timeless. 17 is always 17, but the way we tend to use values in code is the number 17 comes into your function and then off it goes, right? It's just this int came in, this another int left. It's just this temporary ephemeral value, right? And you get nice math, pure functions, local reasoning and testing. And the first, I've had this slide for like way too long, 15 years. Because I gave it to when BlackBerry went from doing Java to C++. They looked around and said, hey, C++, teach us. And there was a bunch of guys who actually had done C++, but then they'd been doing Java for a bunch of years. They're coming back to C++. And they were all worried. They're like, oh no, pointers. I don't want to deal with pointers in my C++ code. And then it was like, oh, no pointers. Not to mention that Java is full of pointers. They're just not called pointers. Once again, thanks, Ben. And don't forget this one. And that's it. Questions? Yes?
If you could go back to that slide where the color model was.
No, that scares me. It means you have it very specific.
Well,
We'll get there.
I have a question. But,
Sure.
Okay, so yeah,
We'll do
this one.
yeah.
So, looking at this, I would actually say, okay, I don't want to write this, this code like this in every place in my code. So, and in particular, I don't want to remember what I don't know tetrad near complement is.
Yeah.
At least, in my case, until I get the paintbrush. In your case, until I get the projector. Okay. So I would say model is actually defined not by this word, but by what it does to colors. So these things should be basically interface on the model, and the set of transformation that it does to colors, and if you include like tint and shade to luminescence as well, is what definition of the model is. Yeah, it can spit out the
This
how, if I add this bunch of member functions to the model, how would that sort of change? I mean,
Right.
Would it still be a value?
Yeah. Well, I mean, color would still be a value.
No,
right?
the model.
Yeah, but like you're talking about the color matching model, right?
Yeah.
And yeah, maybe that is, it probably shouldn't just be an enum, right? You have a bunch of different color matching models. It could be, you could go back to interface of like, maybe they only have a couple functions. Maybe it is just give me a complement or like give me a matching color. Is that the only virtual function?
Give
maybe,
me a
right?
matching color, give me a matching luminosity if you include tint and shade.
Right. Well, color in this sense is all you get. It's RGB.
Oh, okay. If you want
You
those
know.
three, yeah. Okay.
Right?
Yeah. So
It depends.
that- would that still be a value or like how I mean,
The color matching model is also interesting too because it probably doesn't have any state, right?
well,
Hopefully it has.
other than that thing, but
No, but like if you had 5 different color matching models, right? One that does HLS complements, one that does whatever, and like there's all different ways of. There's a whole science of color matching, and you get a bunch of different models, and they're all implementations of the same interface, and it's a virtual interface, and you have 5 implementations. You just ask, give me the current one that the user likes, and you call some functions on it, and they're virtual functions. And it's very classic object-oriented. That class is probably what Lakos calls a mechanism, and it has no state at all.
well,
And-
other than like basically the virtual pointer.
Yeah, like yeah. Maybe that's fine. Maybe it depends. It depends. Yeah. That to me is a trade-off of the complexity, right? Maybe the enum is all you need. Like maybe it's like, look, this is the only function where the color matching model. Maybe we don't have a whole giant thing about color matching. Maybe this is the only function that does color matching, right? And sure, there's 5 ways of doing it. It's a switch statement, but like that's it. And then when it gets more complicated, and it's like, no, the user wants to have color matching models, and maybe they do have state and all this thing. And then it's like, okay, I'm going to have to refactor this code into color matching model is a thing. And then, is it still a value? Maybe not. That's why that's somewhere in here. I think I forgot to mention, right? Like if I can take circle and shape and turn it from classic object-oriented into a value, I feel like just raised, like at the base of our code, everything's like at the base, all you have is ints and, and primitive types, right? Okay, those are values, right? Should have mentioned somewhere in there too as well if you take an int and you make it a global variable, it's an object now in my world. Because everyone can reference it and you can watch the value change and like it's that int there, it's that global value, right? Whereas normally it has an identity, yeah, right? It has a place. Whereas normally an int is just values, and all our code at the bottom is values. You've got this object, it's got a bunch of member values, But if I can turn my color class and my circle class and more things into values, the amount of values in my code base goes up a little bit, and then I still have objects at the top, right? Okay, my layout class, maybe that's object-oriented. My cameras are very object-oriented because they represent real objects, and my projectors are objects, and my buttons are objects, a bunch of things are objects. Not everything's a value, but then the number of values you start from the bottom up, and you just get, oh, could this be a value as well? Yeah, that could be a value. And my life there's, if you go listen to talks by Wampe Bolivar, all his code's values. Like his UI, his button class, like you get a new UI. When the UI state changes, you get a new UI, right? Because it's functional programming. You could go all that way. I don't go 100%.
Where do immutable data structures fit into this picture?
Exactly that. Go listen to Wampe's talk. His talk is called Immutable Data Structures. Postmodern. The year I did postmodern programming here, he did postmodern programming. There's a theory on the internet that we're the same person. I did a talk called value-oriented programming in an object-oriented world, and his was like value, not oriented, value-oriented design in an object or like it's almost the same title. And he goes really big on immutable data structures because once you have immutability, then you can have reference to it because it doesn't matter, it doesn't change. There's no worry about spooky action at a distance. Yes?
Can you go back to the two-column comparison between objects and values?
I really am getting somewhere. I know that looked like the same lines of code.
I'm going in this wrong direction.
No, I am going in the wrong direction.
So it's kind of implicit in that maybe the difference between objects and values in part is the strict definition of equality, for example, and what you identify as equality. And objects is more flexible, it might not be even there. Don't you think that there is kind of a continuum between values and objects in the sense that as values become more complex, they effectively become objects in the sense that equality has less and less value, less practical value. For example, you always compare two integers. That's great. If you compare two floating points, sometimes it's risky. You compare complex numbers, okay. Now you have a 1,000 by 1,000 matrix. When are you going to compare arbitrary 1,000 by 1,000 matrices? It's useless almost.
Yeah, well,
so they become objects. Also,
yeah.
Also because the lifetime, it took you 1 hour to compute that 1,000 by 1,000. You're not going to throw that away. So it's like as values become bigger, you can force them to be values, but effectively they become objects. And this is just the type of the iceberg. You can say, I have regular expressions. You're not going to compare regular expressions because it's impossible to compare them. So they effectively become objects, although you know mathematically they can be values. Right?
Yeah, there is. Once again, go to Wampe's talk of like he has a diagram. It has almost the same words on it, but he has ones in red, ones in green, and it's a gradient in between. Right? It fades from one to the other. And it's how you use them, right? If you use an int as a global variable or something, suddenly it's object-oriented. As things get bigger, you tend to keep them around and maybe it becomes more object-y, or you treat it more like an object. Also, if it gets bigger, the chances of it getting bad code is increased. So maybe it's not because it's an object that we have so much bad code. Maybe it's just that it's bigger, but they tend to go hand in hand. Vector is still, could be big, could be giant. It still has equal, still has equality. People sometimes avoid it because there's an argument to be made that we shouldn't have used equal on vector because of the cost of equal seems like a low cost operation. And you're like, ooh, that, I've got 1 million items that just got compared inside of equal. Maybe that should have looked like a function. Maybe I should have called standard equal on it. But yeah. I kind of get what you're saying.
No, try that on a graph.
Yeah. But like I have a simple graph. I'm worried now. I've had an 8-hour conversation about equality of priority queues. So I'm afraid to say whether my simple graph, you could just compare the vector bool. No, because you could relabel the nodes. But my simple graph, I don't have equal on it. But it's still a value. Like I still treat it as a value type because I like value types. I don't know, because and it's also, I'm pretty sure my simple graph actually, like the dimension never changes. It's not immutable because you can make connections and not, but it's almost immutable. And it's like, typically I just make the graph and then I use the graph and it doesn't change, right? But so many people with hands up. Yeah?
Hi. Big fan of not getting and setting. Big fan of getting the essences of things, tightly couple things together. But looking at your circle where you're saying, look, I'll just keep moving stuff out till I have a radius, right?
Yeah.
I mean, it's kind of useless just having a radius. The rest of the state is just it simply just shuffled it over to your layout class.
Possibly, yeah.
So I think there is there's some reasoning has to be applied there. Otherwise, you're going to have your state or your functionality splintered all over the place because you made it into like really tiny atomic pieces that you probably do not need to make it into.
Yeah.
And on the copying, it's great with values. Copy, everyone would love to just copy values, but in the real world, when they're big, or you move something, but it turns out to be an array you're moving. Right? You're not moving anything; it's a copy underneath the sheets.
Yeah.
I think it's not as it seems a little trite to say just copy everything, your values, and then take your stuff and break it down into tiny little pieces, as opposed to what I'll call salient or useful abstractions, with the essence of the pieces that don't go together.
Yeah. The point kind of, and that's why I was like, if you're going to leave X and Y in circle, just rename it to circle region. I'll be happy. The real point there is to think about it, right? And start moving things around a little bit, and you're like, oh wait, this might be better. Maybe it's not, right? Either one's an extreme, right? My camera class is too much the one way, and maybe my circle class is too much the other way. My circle class is basically a type def, right? But it's a strong type def, right? I hate type defs. Yes, it's not a type def.
It's a using.
Yeah, but it's a strong one. It's not a using because you can overload. Like it's a unique type.
No, it also has fewer affordances.
Yeah, I've taken stuff away.
Yeah.
Right? Like
That's
you can't add two circles.
That's the most important thing.
Yeah. I've limited what that int can do. Circle plus circle equals bigger circle. Does that make sense? I just find too much code is currently in the other direction. So I might be exaggerating in this direction.
Yeah, I'm living that dream. To give all these God classes, buckets.
Yeah. And also I find, don't tell anyone on the committee or anything, because, C++ is all about efficiency. 95% of your code doesn't have to be efficient. There is a code path in your code that needs to be efficient. The rest, in my other talk about functions, I talk about the same thing as just return the vector from your function. If you're doing that in a loop, it's better to not return a vector. It's better to reuse the same vector over and over again because you can reuse the capacity. It's more efficient, right?
Yes, but you pass it in as a defaulted parameter at the top.
Yeah, you just write two functions that have one, do it this way or that way, whatever. There's so many ways of doing it. But it's that's actually the rare case. It's yes, this piece of code needs to be efficient. Copy, measure it, right? Measure it first, then tell me that, copies are expensive or not. We're gonna go like this. Okay.
So I love the stuff on the right. I love all the value oriented stuff. I try to get things moving more that way. But I want to clarify. I think maybe it's just for my own mind, because I find that I disagree with a lot of stuff you say about object oriented programming stuff. But I think it might be because we think of objects differently. Your definition of object is not the C++ standard definition of object. It sounds like to me your definition of object and maybe your experience of object-oriented programming is everything is these abstract types. Everything has, all the objects are identity objects, and as you say on there, polymorphism. But I assume that means dynamic dispatch with virtual functions and all of the stuff, the way that these things are.
Yeah.
And that's your definition of objects and object-oriented programming, right?
Yep.
Okay. Thank you.
Yeah, because it really is the oriented part, right? And it's just Yeah, like because you can just have a class, you know, the C++ definition of object, or just like a class is an object, but the classical object-oriented just tends in this one direction, and just gets worse and worse the farther you go in that direction, right? And you can be somewhere in between. You can have nice. Here's an object that you know, doesn't have a class hierarchy and everything, but I still call it an object. But like soon as it's the orientation. Do I treat it as if it was an int? Do I treat it like a value? Do I just pass it around like a value, or do I treat it like an object where it has identity and it changes over time? And you know, and it's a fuzzy middle, but you know, it's like you tend to this direction or you tend to that way. I often tell people when they start writing a class, decide right then, should it feel object-y or should it feel value-y? It might get used, you know, but you write it in class, you probably know how you're going to use it. And one of your first, like, is it going to have a copy constructor? Is it going to have equality? You know, all these things, or you're like, no, those don't make sense here, or they do, and then you're like, oh, maybe this is going to act like a value. Anyhow, Ben.
So if you're breaking these parts out, to Pete's point, if you break the X, Y out of the circle, you break the color out of the circle, it seems to me you're going down the road of an entity component system architecture.
Maybe.
Right? So values are components, objects are entities, and systems are for efficiency.
Yeah. Yeah, entity component system, maybe. I haven't played with it enough. You know, I haven't lived it enough to say yes or no. But yeah, similar, but you had a thought on that, I could tell.
Yeah, so in graph code, we have this notion of internal and external properties of nodes, right? External one, like they're both one-to-one with nodes, right?
Right.
But given the needs of your algorithms and their performance, you can either put them inside the node, co-located with the node, or you can have, I don't know, a hash map or a vector that you index into given the node ID or whatever.
Annotations.
Yeah, like and usually like all of these really has to do with the node are intrinsic properties, and everything else is an extrinsic property, except once you measure you realize you can't afford the cache miss, and then you put it inside the object, and that's how you end up with the location inside the phone.
Yeah.
Right? And at that point, thank you very much. You should rename the damn node class,
yeah.
Right?
But like this is a weird one for me because I used to spend a lot of time talking with Sean Perrin about that, and we both were like, yes, this XY should be an extrinsic and all this stuff. And I've like internalized it so much that I forget why I got there, right? But I still know that I like asking the question. And I'm like, hey, should this be part of this class, or is it? And even if you just recognize it, it's, oh yeah, this is a relationship between this class and the layout. But okay, we're going to keep it here for reasons, right? And just like ask yourself on these things, is like, is this really part of this class, or is it we keep it here because it's one-to-one with this class? Right?
And to your point in a previous talk of yours, leave a comment.
Yeah, leave a comment.
That's what deserves a comment. This does not belong here. It is here for this reason.
Yeah.
Just an observation that, so I noticed that, like I'll start with a concrete observation, like when you moved XY from circle to layout class, the price you paid is that layout, layout instance or whatever.
Layout object.
Layout object. You can no longer tell at compile time whether it's a circle or not.
Yeah.
But kind of, I was thinking about that, and that's something more general. You haven't the compile time polymorphism, or in general the generics, don't seem to figure into this picture at all, and you very casually sacrifice all the compile time type system abilities. You basically have runtime polymorphism and basic values. Seems like somewhere in between there is a place for for things we call compile time polymorphism and related.
Yeah, but there's another thing going on here too. Shoot, where was I going to go with this? Often what happens is this stuff becomes the base class of your shape object. And then the circle part of your shape object is a derived class. Like every circle and every rectangle and everything, has a position, has selected or not, has a style. So you shove that all down into your base class. And then on top, you put the differences. Well, this one's a circle, this one's a rectangle. I derive
But
from
now again,
my,
circle has an XY.
right?
You flip it back to.
No, but like,
Shape is a base class. The derived class has all the data members of the base class.
yeah, right? Like in traditional, the classic example of, circle is a shape, derives from shape. And we wanted all these properties on every shape type. You would put all this in the base class, and the only thing in the derived class would be radius, right? And square would have something, rectangles would have whatever, but a bunch of stuff would be in the base class. And you're like, great, because it's all common.
But then two circles at different XY are not the same anymore.
Sure, I don't care about that part. I just want to talk about, like, note that this is flipping that relationship up around.
Yeah.
It's like, here's the common stuff, it's in this class. Here's the different part, it's separated from the class. And it's like, sometimes that's a better way to do it. It's like, yeah, layout objects have all these properties. Every layout object you have a bool selected. Is selected is not a virtual function anymore. Circles can't be selected differently than any other shape is selected, because you probably don't want to. Why did you make it a virtual function? Oh, we put it in the base class. It didn't have to be virtual, but we made everything virtual because shape is pure virtual, blah, 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 blah. And we stuck, and you end up with like some state, it's not pure virtual, it's like part abstract class with some state in it, and some of the state is out. Half the things are pure virtual, half the functions are, and you're like, no, none of these, there's no virtual functions here. And there's like one, here you're gonna end up with not virtual functions. Draw is gonna be outside the circle class. You're gonna have a visit type thing, right? But it's not always, like, which one's better? It depends. But like, I really like the idea of like, I had a student years back that was the best I've ever had at refactoring code. And he just took stuff, saying, oh, look, this is all common. He put it in the base class. He's like, this is all common. And all his base classes were called base and common. And I'm like, what is this thing that you made? He's like, I don't know. It's the common stuff. I'm like, can you name it? Can you tell me what this is? And he's like, and I'm like, I remember, like, this is your only mistake in your life of like, this guy was such a good programmer. And if he's watching, he became like the director of Premiere and then of all of digital video audio, and went like, he just brilliant guy. But like, I was just like, here's the one thing I want to tweak of your, like, don't put everything in the base class. And it's brilliant guy. His name's Steve. Steve, if you're out there. So
you could make layout object template instead.
You can make that a template, and then the circle layout object is here.
That would be
But then everything I do with layout object has to be templatized. My whole layout's going to end up full of templatized functions.
Yes.
All this stuff doesn't need to be templatized.
But at the same time, at compile time, you would know what that particular layout object is.
Is that important?
Yeah.
Compile,
I
in this
prefer to get
case?
compile time errors. I prefer to get compile
I like
time
compile time errors, yeah.
important.
But like when I do the visitation on this and turn it into compile time, you guys should see my image class, because it holds unsigned char array of pixels, which might be floating point pixels, or RGBA, or just RGB, or just gray A, float, char, short, or int, and it's all just in one pile of bytes. And then there's, oh my God, I have to do a switch statement on what's the format, and every switch statement calls a templatized function, because I then take the format, turn it into a template param, so all my composite function is one function, right? But it's the dynamic to compile time.
Yeah.
Maybe end up with some of that here. I don't know. You've been asking. You've had your hand up a long time. No?
If you go back to the slide of objects and values.
Yep. Everyone's favorite slide.
Under values, you have immutable.
Uh-huh.
Right above it, you have movable.
Uh-huh.
Is there a conflict there? If not, why not?
No. The second part's the hard part. Yeah, I mean, oh man, the Queen of Clubs. Oh, maybe I should.
I know what you mean.
Yeah, you saw this talk, right? Is the Queen of Clubs a value or an object? right? And it's just like the card class, it's got a rank, like the number, and it's got a suit. Like it, not only is it just 2 ints, it's like 1 char. There's not a lot of information there. You can fit in 1 char. But I don't want to copy the queen of clubs because then suddenly I have 2 queen of clubs in my code base, right? Or in my like running program. That would be a mistake. There's 1 queen of clubs. It's the queen of clubs, unless I have 2 decks, blah, 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 right? So I have a card class, and I wrote this card class, and I started writing the copy constructor, and I was like, should it have a copy constructor? I don't know if it should have a copy. I don't want to make copies of the queen of clubs. And then I was like, okay, I'll make it move only. And then like, okay, if I make it move only, what's the move from state of the queen of clubs? And I'm like, now I have to have a null state in my, I don't want to have a null state. I have a deck of cards. None of them are, I mean, you get that extra blank card in your deck of cards, but like, I don't want that to exist. And then I spilt water on the laptop and I had never finished that project. True story. Yeah, but like, I mean, there's a limitation of C++ that we're still trying to solve with destructive move and relocation and all these other things. In my case, I knew that the only piece of code that should be able to move the queen of clubs was like the deck class, because that is the owner of the queen of clubs. And then you start getting into the whole part relationship of like, who does own the queen of clubs? Oh, it's part of the deck, and the deck has a vector full of things. And maybe you could take it out of the deck and put it into your hand, and these things should be able to get the move from queen of clubs, because you know that vector is just going to throw it away. So it's like only going to exist for a moment, and then it's gone. But like, how do you like? You want to like give friendship of the move from state to the deck class and the hand class, and nothing else can have it, or something like that. We don't have a solution for that. How about no more questions? How about we're done? Unless someone's got their hand up, I don't see any questions. All right.